All right, so if you are struggling with your homework today or yesterday's homework, hopefully this will help. So as a reminder, we talked about yesterday how you can take your x value and your y value and substitute them in and decide whether it's a true statement. If it's a true statement, then we get to say that it is a solution, and if it is not a true statement, then we get to say that it's no solution, or not a solution, excuse me, not no solution, not a solution. There's lots of solutions out there. So we've got 2 times negative 5 plus 12. So that's negative 10 plus 12. So we have to decide, is 2 greater than negative 5? Well, yeah, 2 is greater than negative 5, and so we'll say yes, that is a solution. Let's do one more here. So if we did 5 times negative 3 plus 2 times 6, that gives us negative 15 plus 12, which is negative 3. Since negative 3 is less than or equal to 8, it's a true statement, and we say yes, it is a solution. And if we did 4 times 6 minus 3 times 8, 24 minus 24 is 0. 0 is greater than or equal to negative 5, so that one is also a solution. So all three of those were solutions. If it had started out as less than, and we ended up with 0 less than negative 5, that's when we'd say no solution, because that's not a true statement. All right, so yesterday we talked about how less than and greater than, they have the dotted lines, and then less than or equal to and greater than or equal to, they have the solid lines when you go to graph your inequalities here. The reason for that, again, is because the line represents everything that it's equal to. So when we add the equal to bars, the line becomes part of the solution, versus the dashed line, where it's cannot be equal to, it can only be bigger or smaller than the given values. That's why we use the dotted line to represent the fact that it's not part of the solution. We talked about yesterday how it's kind of like the open circles not part of the solution and the closed circles being part of the solution, where it could be equal to 3, versus up here where it could not be 3. Only things smaller than 3. And so we had these steps. You're going to graph using y equals mx plus b. Just pretend like your inequality is y equals mx plus b. If you have something like y plus x less than 5, you want to make sure it's in y equals mx plus b slope-intercept form. So you would need to subtract x on both sides. And then go from there. Then you'd have a slope of negative 1, a y-intercept of 5, and you could graph from there. The second step here is going to be to shade. If you have greater than or equal to, you're going to shade above. And if you have less than or equal to, you will shade below. So let's take a look at our first example here that we did yesterday. You've got y. You've got a slope of 2 over 1 and a y-intercept of 4. Remember, y equals mx plus b. So that's where our slope and y-intercept came from. So I go over here and I start at 4, a y-intercept of 4. And then it's going up 2 and over 1, up 2 over 1, up 2 over 1, down 2 over 1. And you can graph as many of those points as you want before you try and graph it. It's less than, so we're going to use a dashed line because it's not equal to. So there's my y equals 2x plus 4 boundary line. And then we have to shade. And so what I would do is I would come down to one of these points. And since it's less than, we want to shade below. So I'm going to go down from this point, which is over here. And then I'm going to shade everything that is on that side of the line. It doesn't have to be perfect, but we do want to try and shade as much of it as possible. Okay, make sure it's definitely clear that that is what we're trying to shade. What we don't want is for you to just call that shading. That's not good enough. We want to shade in as much as that space as possible. Doesn't have to fill in every blank space, but try to get it close. That's good enough. Okay, so the next one here, we have a y-intercept of -1. And we have a slope of 3/2. We are using less than, so we're going to use a dashed line. And so we're going to start at -1. And we will go up 3, 1, 2, 3, and over 2, 1, 2. So there's one of my points. And then I can go down 3 and over 2 as well. And so now I have 3 points that I can use to graph with. Again, we're using that dashed line this time, so we're going to draw a dashed line here. Draw some arrows on the ends. And now we need to decide whether we are going to shade above or below the line. Above the line for greater than, so I'm going to come to one of these points, and I'm going to go up, and I'm going to shade above the line. That looks great. As a reminder, the reason we are shading above the shaded region is telling us all of the points that will make that statement true. And so if I change colors here, and let's look at -3, 1. -3, 1 is right there, and it's in the shaded region. So if I use the point -3, 1, I should get a true statement. And so 1 is my y. 3/2 times -3 over 1 minus 1. So 1 has to be bigger than -9/2, which is -4.5, minus 1. Well, yeah, 1 is greater than -5.5. So it does give us a true statement because that green point is in the shaded region. And then any other point in that shaded region would also give us a true statement. If we chose a point over here in the not shaded area, that's going to give us a false statement because it's not part of the solution. Only numbers in the shaded region are part of the solution. And since we have the dashed line here, anything on the line is also not part of the solution since it cannot be equal for this example. Alright, let's go with this one. So we've got a slope of -2/5. You have a y-intercept of -2. So we're going to start at -2. You're going to go up 2 and over 5. That's good enough for graphing. We can go ahead and use a dotted line again. Oops, I missed it. My hand was obstructing my view. So let's try that again. That's a little bit better. So draw arrows on either end. It's less than, so we are going to shade below. Perfect. Let's find one where it is an equal to. There we go. We got m equals 1. I just wanted to go back and check. So this one had a positive slope, so we were going up and to the right. This one had a positive slope, we were going up and to the right. And then this one had a negative slope, we were going down and to the right. Next one here, we were going to do this one. So b is 1 as well. So we're going to go up to the y-intercept of 1. We're going up and to the right. Up 1 and over 1, down 1 and over 1. Gives us lots of points to choose from. We need a solid line this time because it's got the equal to, and the line shows all the values that are equal to. And then we are less than or equal to, so we're going to shade below the line. This is everything that's below the line. Perfect. Let's do one more of these, and we can look at the special cases. So we got y-intercept of 2, a slope of 1 over 4, so we're going up 1 and over 4. Dotted line, because it's less than and greater than have the dotted lines. Only if it's equal to, you have a solid line. My dotted line's a little off because I'm not using a ruler right now. But we are going to go less than, so we will shade below. So that we've done several examples and you're starting to figure this out. Let's go back to, again, you're using a dotted line for less than and greater than. You're using that solid line for less than or equal to and greater than or equal to. You're shading above for greater than and greater than or equal to. And you're shading below for less than and less than or equal to. I've got 3 minutes. Screencast-o-matic only lets us do 5 minutes or 15 minutes at a time. So y is greater than 7. We want to graph the line where all the y values are 7. We're going to use a dotted line to do that because it's greater than. And then also for greater than, you need to shade above. X is less than or equal to -5, so it's got a solid line where all the x values are -5. That line that I just drew is all the x values being -5. You got -5(1), -5(2), etc. And then it's less than or equal to. Since it's less than, we're going to shade to the left. That's the only weird thing, is that for anything as x inequality number, there's no y present in the inequality. You do need to shade left or right. Left for negative, right for positive. We talked about how going up is usually going up is positive on a coordinate plane, and so greater than and greater than or equal to go towards the bigger positive numbers, and going down and left is the negative numbers, and so it's getting smaller and smaller the more negative you go. And so that's why we go left and down for less than or equal to, because it's pointing towards the smaller numbers, versus greater than equal to, it points towards the bigger numbers, up or to the right. Last one here for this video. You got y is less than -4, so we're going to draw a dotted line at -4, and we're going to shade below. All right, that's it for this one. I'll do a few more examples in another video, and have a great day and make good decisions.